For today's notes, you'll need in class 54. This is part 1 of standard 13, where we are going to learn about right triangle trigonometry. Sometimes teachers will abbreviate the word trigonometry as just trig. So if you hear that, they're talking about the same thing. The goal of the lesson today is to introduce a lot of the vocabulary and the terminology that you'll need in order to be successful at using trigonometry to solve problems. So, the three main ideas for our trigonometry unit are focused on these three ratios: the sine ratio, the cosine ratio, and the tangent ratio. Sine is abbreviated as SIN, but we still say sine. Cosine is abbreviated as COS, but we still say cosine. And tangent is abbreviated TAN, but we still say tangent when we see that. So the way that these ratios are set up is that they require an angle. That's what this theta is equal to. That is a Greek letter, THETA is how you would spell that, theta. We use that as the variable for an angle. Cosine of theta, tangent of theta. So all three of our trig ratios require an angle as an input, and then what they equal is a ratio of sides. So for sine, opposite over hypotenuse; for cosine, adjacent over hypotenuse; and for tangent, opposite over adjacent. And so what's happening is this theta that we're talking about is actually what we call the reference angle. And so that's the angle that we use when we're trying to make decisions about which part of a triangle is the opposite, which part of the triangle is the adjacent. We don't use the reference angle when we're making a decision on the hypotenuse. We know that the hypotenuse is always across from the right angle. So that terminology should be familiar to you from our Pythagorean theorem days or from our congruent triangle, HL, hypotenuse leg days. But the others, opposite and adjacent, will depend on which angle of the triangle is our reference angle. That's why in these descriptions, they're asking us for the opposite leg to angle A. This is our reference angle. So when our reference angle is angle A, that means we set ourselves up at angle A, we pretend we're standing there, and then we think about which side would be opposite where we are. So not one of the two sides that is forming angle A, but the one that's on the opposite side of the shape. So for this situation, we would be talking about segment CB. If we go through our options, right there, number 5 is segment CB, just with the letters backwards. So this would match with option number 5 from our list. If we're going to think about the sine ratio of angle C, our reference angle will change. So let's hold off on that one for right now. Opposite angle to side AB. Well, we could probably figure that one out. If we're over here at side AB, we use a different color. That's connected to angle A and angle B. So the opposite angle would be angle C. That's going to be option 3 in our list. We said the hypotenuse is always opposite the right angle, across from the right angle. So that's going to be this third side here, AC. That's option 6 in our list. Here's another one that uses reference angle A, so we can go back to our little smiley face. The adjacent leg to angle A. Adjacent means next to. This next to side for angle A already has a name, the hypotenuse. So when we're talking adjacent, we're talking about the leg, the part of the right angle, the side of angle A that is not the hypotenuse. So that would be segment AB or option number 4. Tangent ratio, again, switches our reference angle up on us. So let's stop. Let's not do that one quite yet. This one asks us about a reference angle, so we'll come back to that one. H is the adjacent leg to angle C again, so that's a different reference angle. Let's tackle I, the cosine ratio of angle A. So we're going to be able to keep using this as our reference angle. A quick check at the top says that if we're doing the cosine of an angle, in this case angle A, it's going to equal the adjacent side over the hypotenuse. So if we're at angle A, we just said the adjacent side was AB, so that would be on top. And then the hypotenuse was AC. That would be on the bottom. So we're looking for one of these fractions over here, these ratios, that has AB over AC. And I think that matches number 8 perfectly. So number 8 is going to be the cosine ratio for angle A. The longest side of the triangle is always the hypotenuse, so that's going to go back and use AC, or option 6, a second time. And then we've got a couple of different, or one more place where we're going to look for a reference angle. All right, I think at this point in time, the best thing to do is to go back and tackle the ones that have to do with angle C. So I'm going to change my color. I'm going to put a green smiley face here at angle C for our reference angle. This one is asking me for the sine ratio. So if I go check out my information at the top, the sine of theta is supposed to be the opposite side over the hypotenuse. So if this angle C is our new reference angle, the opposite side is going to be away from angle C, between A and B. So that will be the numerator. And then the hypotenuse, back to that same AC side, is going to be the denominator. So I'm going to use that same option number 8 that I already used earlier. So that brings up an interesting point. The sine ratio of angle C and the cosine ratio of angle A are actually the same thing. Something to keep in mind. All right, next up, still with angle C, we're down here at letter F, the tangent ratio of angle C. Let's go check out what they're telling us about tangent. The tangent of C is going to be the opposite side over the adjacent side. So if we come look at our picture, angle C is here. The opposite side would be that pink highlighted one. So AB would be the numerator again. But this time we want the adjacent side, so the side right next to angle C that's not the hypotenuse. In other words, this one right here, BC or CB, to be the denominator. I think that's going to match best, with option number 10 down here. AB over BC is the tangent ratio for angle C. One more that has to do with just angle C, and then we'll go back to these ones right here that have reference angle questions. The adjacent leg to angle C. So back to that reference angle C. This side of angle C already has a name. It's the hypotenuse. So that means this one right here is the adjacent leg. Segment CB or BC, right there, is going to match with option 5. Okay. These other two are going to require a little bit of a different way of thinking. So when we're thinking about BC over AC as being cosine, cosine is supposed to be adjacent over hypotenuse. This matches up. AC, hypotenuse, we knew AC was the hypotenuse, so that's not going to be very helpful in identifying the reference angle. But thinking about how BC is required to be the adjacent absolutely will help us to choose. If BC needs to be the adjacent side, that means that C has to be the reference angle. We couldn't use A as the reference angle because then BC wouldn't be adjacent. We don't use our right angle as a reference angle. It's always going to be one of the two acute angles. So if BC is the adjacent side, angle C, or option 3, must be the reference angle. All right, one more. We've got the same ratio, but this time they want to know the reference angle if this is the sine ratio. So if we peek back up at the top, sine is supposed to be opposite over hypotenuse. So again, that denominator doesn't help us, but if we think about BC as being the opposite side, now that forces me to use angle A as my reference angle, because then BC would be on the opposite side of that triangle. Angle A is option 1.